Hi there, today we're going to be talking about solving inequalities by addition or subtraction. Apologize ahead of time for the background noise. Today we're hanging out in the airport in Louisville, Kentucky, waiting for our plane to arrive. Here's a little snapshot of what our setup looks like today. Hanging out in a Starbucks with the projector facing up against the wall. It's going to be an exciting time, but it should be a little quieter than our Las Vegas stop, which was much louder last time. So, here we go. When you're solving inequalities, it means we're looking for the values that the variable could be that make an inequality true, which means it can be a range of numbers depending upon the situation, okay? So we're going to use our subtraction addition properties like we did for equations, but now instead of having an equal sign, we have an inequality, that greater than or less than sign, and sometimes greater than or equal to or less than or equal to there, okay? Which means that any number that's greater than or less than that given value would work to solve that equation, okay? So when we take a look at our first one here, we have x plus 4 is greater than 9. So again, what we want to do is we're trying to isolate the variable, which is x right there. So to do that, we're going to subtract 4 from both sides. So just like we did before, this gets a positive 4, negative 4, and 9 minus 4 becomes 5. Which essentially means this is what we're talking about. That if I had a number line, okay, and I have x plus 4, I'm trying to say what value of x can I have that I add to 4 and I get an answer greater than 9. And what we're saying here is that if I had 0 and then 1, 2, 3, 4, 5 up to there, is that any number from 5, and we're going to make that an open circle, this direction would work. Because if I have 5 plus 4, that's greater than 9. If I have anything bigger, like 6 plus 4, that's greater than 9 as well. And so we continue moving in this direction all the way there. Now I keep that an open circle because it is just a greater than or less than. If it was a greater than or equal to, then we close that circle up, which we'll see in just a few moments, okay? So, on the second one, we have negative 12 is greater than or equal to n minus 9. So again, the same idea, we're going to say negative 12 greater than or equal to n minus 9. The goal here is to get the n, the variable, by itself. So we're going to add 9 to both sides, which means that's eliminated there. I have a 12 and a 9. Those are different, positive and negative, so I find the difference. 12 minus 9 is 3. And the one with the greater absolute value in this case is the negative number. So we bring down our greater than or equal to and the n, which means the value we're looking for is any value of n we're looking for is going to be less than or equal to negative 3 to make this true. Okay? Now again, you could graph that out if you chose to, which would be something along these lines. We draw that there, and we have any number less than or equal to negative 3. So if 0 is there and negative 3 is there, we would have a closed circle at negative 3 because of that line there. And we want to say any number less than, which means it's going this direction, would work to satisfy that inequality. And that's how we graph that there. Okay? Our last example here, it says solve a plus 1/3 is less than 1, and then graph the solution set on a number line. So you can see we're working with a fraction, still want to isolate the variable just like we did before. And so in the example here, we're going to subtract 1/3 from both sides. Subtract 1/3, subtract 1/3. You see that the less than comes all the way down, and we isolate the a. So all we're doing is we're eliminating this 1/3 by subtracting it, so it goes away. And over here, the actual computation is 1 minus 1/3, which is 2/3. So a has to be any value less than 2/3. So in the number line, you can see that they went 0 there and 1. Made a mark here where 2/3 is going to be. It's an open circle because it's just a less than value, not a less than or equal to value, right? So we're not doing that. That'd be close. And it's any value less would actually work there. So what you'll be doing today is some more like this, solving some different inequalities. So let's take a look at a couple together real quick before we move on. I'm going to add 6, get the variable t by itself. So t is going to be greater than 3 plus 6 is 9, and that's all there is to it. When I look at 3, I can add add 9 to both sides. That goes away. 8 plus 9 is 17, is less than r. Okay, and that's all we're doing with the addition and subtraction part. These are really one-step inequalities. They're not equations because they don't have equal signs, but they're one-step inequalities. If you have to go on and actually graph one, solve and graph, which is this part, solve and graph, we could do that here. We would say s plus 8 is less than 9. We want the s by itself, so let's subtract 8 from both sides. That goes away. So s is less than 9 minus 8, which is 1. So I'm going to put a circle on the 1, and s has to be less than. Less than means this direction. And I draw an arrow that way, meaning it's going to be any value less than 1. It could be negative 2, it could be negative infinity, for there, ever and ever and ever. Let's do one more graphing one. So we have negative 3 less than or equal to d minus 2. So we're going to add 2 to both sides, as that goes away. These signs here are different, so we're going to find the difference and keep the greater absolute value. 3 minus 2 is 1. We have negative and positive. This one's larger, absolute value. So negative 1 is less than or equal to d. So in graphing this one, I'll make a circle at negative 1, which is here. And we're going to fill it in because it's less than or equal to. And we're going to say less than or equal to d. Or sorry, we're going to say d is greater than. I got to look at what I'm looking at here. So d is greater than negative 1. So d is greater than negative 1. So when you're looking at how do you draw the graph, I like to read it from the variable forward, okay? Because we're talking about d. So the value of d has to be greater than that. So you could actually rewrite it if you wanted to. It would look like this: d is greater than or equal to negative 1. So the sentence, that's probably the better way to read that one. Okay, so that's what we're working on today. You have some problems to practice with, so good luck with that. I'll see you here in just a minute. Alright, here we go. Let's look at your homework for solving inequalities by adding and subtracting. I'm going to use a piece of paper here because there's not much room here to solve these. So for number 1, we had p plus 7 is less than 9. So I'm going to subtract 7 from both sides, so that goes away. And I'm left with p is less than 9 minus 7, which is going to be 2.
There's an exit right here.
Let's take a look at number 3. Number 3 is right there. I think you can see that. Yeah, you can see 3. So 3 is negative 13 is greater than or equal to 9 plus b. Again, the goal is to get b by itself. So let's subtract 9, subtract 9. That's going to be eliminated. Here the signs are the same, so we find the sum and keep the sign the same. 13 plus 9 is 22. Greater than or equal to b. So b is less than or equal to negative 22. Let's take a look at number 5. Number 5, we have 3 is greater than or equal to negative 2 plus y. We're going to add 2 to both sides to get the y by itself. That's eliminated. 3 plus 2 is 5, so 5 is greater than or equal to y, or we would really read it as y is less than or equal to 5. We want to read it that way. Okay, number 7. Slide back over here. 7. So r minus 5 is less than or equal to 2. We're going to add 5 to both sides. That goes away. So r is less than or equal to the sum of 2 and 5, which is 7. Okay. Let's look at number 9. So number 9, we have j minus 8 less than or equal to negative 12. We want to get the j by itself, so we're going to add 8 to both sides. So that j is less than or equal to, that goes away. I have a negative and positive, so I'm going to find the difference because the signs are different. 12 minus 8 is 4, and keep the greater absolute value, which is in this case negative. Number 11. We have 22 is greater than w minus a negative 16. Remember, when we're subtracting, what do? We say we're going to add the opposite, which is great. Now in this case, we're going to go ahead and subtract 16 from both sides, eliminating that. The signs here are different, so I find the difference. 22 minus 16 is 6. The greater absolute value is a positive one, so we leave it as positive 6 is greater than W. Alright, number 13. Have a decimal there, not a big deal. So 1 plus y is less than or equal to 2.4. So we're going to subtract 1 from both sides. I think the thing here you might need to be careful of is that you want to make sure you line up your 1 with the correct placeholder, right? It's negative, it's right there. Add a 0 there in a decimal. So 4 minus 0 is 4, and 2 minus 1 is 1. So y is less than or equal to 1.4. Alright, let's look at number 15, which I think I can do on the paper here. There's space for 15. So 15, we're going to add 4, and I can write 4.0 if we want to. So that f is equal to, f is greater than or equal to 5.4. So those are our solutions for that first part right there. It does say to check your solution, which means plug it in and see if it works. Okay? Now in this next part, it says to write an inequality and solve each problem. So let's take a look. This is 4 more than a number is no more than 12. So think about this. So 4 more than a number. So let's call the number n, and we're going to say 4 more than that number is no more than 12, which means it has to be less than 12 for sure. So it can't be more than 12, but can it be 12? No more than 12 would say, yeah, it probably could be equal to 12 there, because it can be 12, just not more than 12. So we'd say n plus 4 is less than or equal to 12. That's probably what our equation would be there, our inequality. We would subtract 4, so n is less than or equal to 12 minus 4, which is 8. 19. The difference of a number and negative 5. So the difference, which means subtraction, of a number and negative 5. So a number and negative 5, the difference, subtraction, is less than 7. So we'd set it up like that. So the difference between a number and negative 5. So that's our equation. We would add the opposite. And to get rid of this, I'm going to subtract 5, so n is less than 2. Number 21. 11 less than a number. So there's a number. 11 less than it is more than 15. So it's greater than 15. Doesn't say it's 15, can be equal to 15. It has to be greater than 15. So we would keep it like that. So we're going to add 11 to both sides, and our n is going to be greater than, in this case here, 26. Okay, let's take a look at some of the graphing ones real quick. So we have t plus 7 is greater than 12. So to solve this here, we're going to say, pop over here to the side so we can see have some room. So t plus 7 is greater than 12. We're going to subtract 7, so that t is greater than 12 minus 7, which is 5. So we'll put an open circle at 5, and then our arrow goes this way forever and ever and ever. Number 25. We have negative 13 is greater than or equal to x minus 8. We want the x by itself, so we'll add 8 to both sides, eliminating that. The signs are different. Find the difference. So the difference between 13 and 8 is 5. The greater absolute value is the negative number. So negative 5 is greater than or equal to x. So one thing we said before is it's best to read these with the variable first. So if we do that, we change the sign around. We're going to read it this way. So x is actually less than or equal to negative 5. So on my number line, I'm going to go to negative 5. It's less than or equal to, so I'm going to fill it in. And my value has to be less than that. So less than that means I'm moving this direction for my inequality, my arrow there, graphing it out. 27. We have 3 is less than or equal to 1/2 plus m. To get the m by itself, I'm going to subtract 1/2 from both sides. So 3 minus 1/2 is going to be 2.5 is less than or equal to m. Not sure how that worked out, just think about it logically. I had 3, I'm getting rid of half of something. So half of 1 is a half. So that was pretty much a mental math one. Again, rewrite that. So m is greater than or equal to 2 and a half. So I'm going to find there's 2, there's 3, here's 2 and a half. It's a filled in circle because greater than or equal to. And greater than means it goes that direction. And there we are. Alright, number 29. Rewrite this one, so we have some space here. Negative 3/4 is less than w minus 1. And add 1 to both sides. So w is there. We have 3/4 and 1. Okay, so you're thinking about 1 minus 3/4. If I put this as a fraction, it'd be 4/4. So 4 minus 3 is 1. So we have 1/4 as our solution, or w is greater than 1/4. So for fourths, we have 1/4, a half, and 3/4. And w is going to be greater than that, so we're going to put a line there, arrow there, open circle, and we're done. Okay, that's it for today. Have a great day. We will see you next time.